Hey everyone. All right, so we're going to talk about transformations with shapes. The first one we're going to talk about today is this idea of translations. So when we did translations with functions, we did something a little different with it. So we're going to talk about the difference between the functions and what we're about to do with shapes. So the transformation piece, the actual transformation is the act or operation of moving an object, whether it's a function or a shape. Okay. So then we have a few things. We have pre-image and image. So this pre right here means before. So the pre-image is the image before the transformation. Okay. So that would make sense. Pre-image would be the image before you move it around. So then the image is the object, so the function or the shape after the movement or transformation. So I'll put movement in here because it's the same thing. So what this will look like notation wise is for the pre-image, let's say we have a triangle, it'd be triangle A, B, C. After you move it, it would be triangle A prime, B prime, and C prime. So these little apostrophes mean prime up here, which means that you've moved this triangle. So now this is the new triangle. Same coordinates in a different place. So we use the little apostrophe here to notate that. All right. So then translation here, when we talk about translation with shapes, it's the act of sliding. So you're going to slide the object. There we go. So translation, when we talked about functions, was moving left, right, up, and down. We're still going to do these things, but we're going to talk about how it slides in those positions. So it's the same idea, just a little different. So we're going to look at example one. Example one, the figure shows triangle ABC. So we're going to graph the image of the triangle after a translation of 5 units to the left and 3 units up. Okay, so we need to first find our coordinates x, y before our movement. So this is our pre-image. So we're going to find the coordinates of A. So for A, we're at 1, -3. For B, we are at 3, +1. And C, we're at 1, 2, 3, 4, 1, 2, 3, 4, 5. We're at +4, -5. So once we find our coordinates, we need to figure out what is happening in the transformation. So this is the transformation piece. This is the operations part. So if we remember from our transforming equations and transforming functions, if we are going 5 units to the left, that means we are going to take our shape and we're going to move it 5 units this way. Okay, and that was when we would take away from our x coordinate. So if we're going to move it, we're going to shift our x coordinates 5 units to the left, which is a -5, so that's why it's subtraction, and then plot those points. So we would move the 5 units left, but then we'd also move 3 units up. So we're going to move up the 3 units, and when we did the transformations with functions, this was our k value, and that would affect our y coordinates. So we're going to take y and we're going to add 3, because remember, moving up and down is whatever the sign is. So we're going to take that and add 3. So to move left and right, remember it's the opposite of what you would put in like the x minus h part. So if we're going to go left 5, that would be a 5, so we're just going to take away 5 in there. So that's the only difference with our shapes versus functions. When we did functions, this was always the opposite of what was in there. But with shapes, we're just going to go ahead and do the straight addition and subtraction. And we're going to keep doing examples of this. So this is the one difference between our functions and our shapes, is how the operations fit in. So if I'm going to move left, and I can count this out on the graph, I'm going to take this first point, 1, 2, 3, 4, 5. So if I took my x value of 1 minus 5, I should get a new value of -4. So I can show you that this actually does work the way it is, because 1, 2, 3, 4, and then 5, sorry, 5, and this would be -4. And then I'm going to take that point and I'm going to move it up 3. So when I add 3 to this y value, I should get -4, 0. And that's where my new a prime goes. Okay, so if the algebra part here is kind of messing you up, you can count it out and get the same numbers. Okay, so keep that in mind. I'm showing you the algebra of the transformation to kind of make it a little easier. If you prefer the algebra, if you prefer counting, do it the counting way. So remember, okay, so we're now on B. So B would be 3 minus 5. So again, I'm taking B, I'm moving left 5, 1, 2, 3, 4, 5. And then I'm going up 3, 1, 2, 3. So that B prime now should be at -2, +4. So -2, +4, that's exactly where I should be. So then C is the same way. I should end up with C being at -1, -2. So when I count it out, let's see what that happens. So 1, 2, 3, 4, 5. 1, 2, 3. So -1, -2, that's where C prime ends up. And then I can connect my lines. Okay, so you can do translations by counting them over, but this is the algebra that's happening with those. So that's the big difference between the functions and the shapes. So make sure that your algebra lines up with counting. All right, so the next one we're going to do is this trapezoid DEFG. So we're going to graph the image so that it's going 3 units to the right. It's a translation, 3 units to the right and 4 units down. All right, so we're going to find points D, E, F, and G. So D, -3, -1. E is at -3, +4. F is at -1, +3, and G is at -1, 0. So the transformation that's happening from our pre-image, this is our pre-image here. So the transformation, if we're moving 3 units to the right, we take D, 1, 2, 3 units to the right. We're really adding over because it's positive. And then we're going to take it 4 units down, so we're going to subtract from our y value. So then we get our image from there. So again, this is the big difference between our function transformation, because we had that formula. Now it's actually moving it that direction, so you're going to show that direction in your algebra. So when I move D, I'm going to take -3 and add it to 3, because that's the transformation. I'm going to take -1 and subtract 4. So when I count, when I'm done, D prime should be at 0, -5. So let's see if that happens. So if I'm going over 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. So 0, -5. That's where D prime ended up. So we're good. Okay, again, I'm showing you the algebra of how it works. when you're doing the translation of shapes, you're moving it or sliding it in the direction it's saying. So if we're going to the right, we're going to the right. If we're going down, we're going down. There's no trickery here. So for E, -3 plus 3 for my new x value, and 4 minus 4 for my y value, which means I should have E prime, my new image, at 0, 0. So let's see if that happens. So if I'm going from E, I'm going to the right 3, and then I'm going to go down 4. So 1, 2, 3, 4. So E prime does end up at 0, 0. Okay, so my algebra is matching up. So for F, if I'm moving it 3 to the right, and then I'm moving it down 4, F prime should be at 2, -1. So let's see if that matches up. So F is going to go to the right 3, 1, 2, 3, and down 4, 1, 2, 3, 4. So my new point is at 2, -1. And so for my last one, -1 plus 3 and 0 minus 4 for the transformation piece, I'm moving it, I'm sliding it over. So my new point should be at 2, -4. So let's see if G prime ends there. So for G, I'm moving it over 3, so 1, 2, 3. And I'm moving it down 4, 1, 2, 3, 4. And that is where G prime is supposed to be. So now I'm just going to connect my lines so that it looks like this shape, but moved. Make sure that you label it with D prime, E prime, all the primes that you need to. But that is how you translate a figure. You're going to take the original image and you're going to slide it to its new position by going left, right, up, and down. Okay? So if you need to rewatch this if you need it, come to office hours with questions, but complete the practice that goes along with it. Have a good day.